All right, today on The Explainer, we're diving into some security research that is, well, it's pretty wild. We're talking about how a simple QR code can be turned into a tool to steal your browsing history. I know it sounds completely impossible, but believe me, it is very, very real.
So picture this. You scan a QR code with your phone, and just like that, the website that showed it to you now knows your browsing history. It sounds like something straight out of a spy movie, right? The website on your laptop suddenly knows which of its competitors you've been checking out. And this isn't some far-off theoretical thing. It's a real attack, and we're going to break down exactly how it works.
Okay, so to really get how this new trick works, we've got to go back a bit. We need to talk about a classic web privacy attack. It's called history sniffing. Now, it's been around for a long time, but as you're about to see, it is definitely still finding new ways to evolve.
So what is history sniffing? At its core, it's an attack that takes advantage of a feature your browser uses literally every single day. It's something that's supposed to be helpful, but it can be turned against you. So what is this feature I'm talking about?
Well, it's that little color change you see on links you've already clicked. You know, how they go from blue to purple? That's it. History sniffing just exploits that visual change. A website can create a whole list of invisible links to other sites, let's say its competitors, and then it just uses some code to check what color your browser makes them. If it sees purple, it knows you've been there. It's a clever and, frankly, a kind of creepy way of looking over your shoulder.
Now, of course, browser makers got wise to this. Way back in 2010, they blocked the most obvious automated attacks. They put in defenses to stop a script from just, reading the color of a link. But that just led to a new kind of attack, user-assisted attacks. These ones trick you into revealing the information. Think of things like weird CAPTCHAs. The big problem, though, they were slow, super slow. You might get a user to reveal 1 or 2 links, but you're not going to get thousands. The bandwidth of the attack, so to speak, was just too low to be a real widespread threat. Well, until now.
So that's the big question, right? How do you get the speed of an automated attack, but without setting off all the browser's alarms? This is exactly where this new research comes in. And the solution they found is, well, it's just brilliantly simple. The big idea? Instead of making you click a bunch of times or type something out, this attack bundles the entire privacy heist into one single, totally familiar action, scanning a QR code. I mean, think about it. It's something millions of us do every day at restaurants or events without even a second thought. But this QR code, this one's different. It's not just a static image. It's actually a dynamic puzzle that's being built in real time from your browsing history.
And get this, the scale of this new method is just staggering. Forget one link per click. In the researchers' proof of concept, a single QR code was able to probe for 4,000 different websites in your history. That is a massive leap in bandwidth. But how do you build the QR code that changes based on a secret, your history, that you, the attacker, don't even know yet? That was the huge technical hurdle they had to overcome. And this brings us right to the heart of the problem. It's this error correction puzzle. How on earth do you build a working, scannable QR code when crucial parts of it depend on the user's private data? To make this whole thing work, the researchers had to solve a really fascinating paradox.
So let's do a quick refresher on how QR codes actually work. They're not just a random pattern of black and white squares. A big chunk of that pattern is dedicated to something called error correction. These are extra squares that are calculated based on all the other data squares. They're what lets your phone read the code even if it's a little smudged or torn. This error correction is absolutely essential, and it's the source of this whole puzzle.
So, do you see the problem here? The main data squares in the QR code, those are secretly the links, and they turn black or white depending on if you visited them. But for the code to be scannable at all, the error correction squares have to be set correctly, based on those data squares. And the attacker can't set them because they don't know your history yet. I mean, that's the whole point of the attack in the first place.
The researchers who discovered this, Keith O'Neill and Scott Yilek, they put it perfectly. They said, "It appears we have a chicken and egg problem." To solve it, they had to figure out a way to make the QR code calculate its own error correction on the fly right inside the victim's browser, all without the attacker's server ever knowing the inputs.
And the solution they found is it's so clever. It uses a pretty new and frankly obscure feature of modern web design, of CSS, actually. They essentially found a way to hide a powerful little calculator right inside the page's styling rules.
Okay, the magic key here is a CSS property called Mix Blend Mode, and specifically setting it to difference. Now, this is a tool for web designers, right? It's for creating cool visual effects by defining how the colors of overlapping layers should blend together. But it turns out it has a very specific mathematical behavior when you're just using black and white, and that behavior is absolutely perfect for this attack.
And here's the truly brilliant part. When you only use pure black and white, this visual design tool stops being about art and color, and it starts being about math. It perfectly simulates a logical operation called an XOR gate. And if you know anything about computer science, you know XOR is one of the fundamental building blocks of all computers. And wouldn't you know it, that is exactly the math you need to calculate a QR code's error correction.
So let's walk through how this visual math actually works. Just think of a white square as a 1 and a black square as a 0. The problem is calculating the error correction, right? So let's say the math needs you to do 1 XOR 1. Normally, you just stack a white square on another white square, and you'd still just see a white square. Nothing happens. But with the CSS trick, the browser is forced to perform a calculation. You stack those two white squares, but the top one has that special difference blend mode. The browser essentially sees white value minus white value, and the result is black, a 0. You've literally just used CSS to calculate that 1 XOR 1 equals 0. It's a tiny computer hidden in plain sight on a web page.
So, by using this CSS trick for every single one of the error correction squares, the malicious website forces your own browser to do all the heavy lifting. It makes your browser do the math. And in doing so, it dynamically assembles a perfectly valid, scannable QR code on the fly. And the final URL that gets created, the one you scan, is now encoded with the results of the probe into your browsing history. Just like that, the chicken and egg problem is solved.
So, let's look at the bigger picture here. This is so much more than just a clever hack. It really highlights a fundamental, recurring tension in web development, this constant push for more and more powerful browser features versus the constant need to protect user privacy.
And take a look at the data from the research paper. This proves it's not just some theoretical attack. I mean, probing 200 links takes less than a second to generate the QR code. Even at the crazy high end, probing 4,000 links takes about 30 seconds. And let's be honest, that's a wait time you could easily disguise on a slow-loading page. This thing is practical, and it is scalable.
So what are the big takeaways here? Well, first, it's a reminder that new browser features, even ones designed for good things like web design, can have totally unintended privacy consequences. They can be weaponized in ways nobody predicted. And second, this research adds a lot of weight to a defense that security folks have been proposing for a while, a same origin policy for visited links. What that would mean, basically, is that a website could only know if you visited a link by clicking on it from that same website. So example.com could only see if you visited other links on example.com, not everywhere else you've been on the web. It would shut down this whole class of attack.
And all this leaves us with a really critical question, one that's going to shape the future of the web. This attack, remember, exploited a feature that was added for visual design. So as our browsers get more and more powerful, as they add new APIs for 3D graphics, for hardware access, even for machine learning, you just have to wonder, right? What other helpful features are just sitting there waiting to become the next generation of privacy bugs?